The last question 4.5. The last question 4.5. Determine an equation of a line parallel to AB passing through point C. Determine the equation of the line parallel to AB passing through point C. Of course, now because we are determining the equation of a line which is parallel to AB and it passed through point C, this tells you that for that line, on that line that we are finding the equation, we have only 1 point. Then it means we cannot be able to determine that the gradient of that line using the gradient formula. Then it means because we have only 1 point there, we must look for something like the perpendicular line or the parallel line. Of course, when we look at this one now, they said that line, it is parallel to AB. Now, immediately when I see the parallel, of course, I'm going to smile. Why? Because I know that if lines are parallel, they have the same gradient. They have the same gradient. Therefore, the gradient of AB is equal to the gradient of the line that passes through what? That passes through C. Now, of course, from here now, I can now say, okay, we have y minus y1 here is equals to m into x minus x1, right? What is the gradient? The gradient there is 1. You remember the gradient of AB is 1. Then from here now, you have the point C. What are the coordinates of point C there? Point C, that is a positive 2 as well as minus 4, right? Now it means x there is a minus 2 and then y there is a minus 4. Therefore, we have x minus 2. This is y plus 4, right? Now we take 4 on the other side. Y is equals to x minus 2 minus 4, which is x minus 6, right? Then that is your answer, right? Boys and girls, of course, one will say that you're always taking this y minus y1 is equals to m into x minus x1. Of course, even if you take y is equals to mx plus c, right, we are still going to get the same answer because this is 1, and now you take 1 point on that line where x is 2, and now y is what? Y is minus 4. Now we are determining the value of c, that is 2, that will be minus 4 minus 2 is equals to c. Therefore, now c is a minus 6. Now, why do I avoid this one most of the time? Because you'll find that most of your colleagues there, or your friends, now you'll find that once they are here, they think now they are at the final answer. No. From here, you still have to write it in the standard form. You still have to write it in the standard form where you have y is equals to x minus what? X minus 6. It is very, please don't leave it here where c is a minus 6. The question said determine the equation of a parallel line to AB. The equation y is equals to something or x is equals to something. Boys and girls, that was November 2009. I believe now you got the question right. Now you understand you need to read the statement, the gradient, you check the angle of inclination as well, the distance you check if the distance is given. Very, very important. Right, now let us look at this one now. Question 5 November 2010. Question 5 November 2010. Yes, here we are in the diagram below. A, B, and C are the vertices of triangle. AC is extended to cut the x-axis at D. Right. Now, the first question that boys and girls is 5 points. You can see, I think in all these papers that I did, the gradient is there. The distance is there as well as the equation. It's very important that the midpoint, of course, I need to mention the midpoint. Right, it means you must be able to determine the gradient, you must be able to determine the distance as well as what? As well as the midpoint. Right. Boys and girls, let us look at 5.1. 5.1 says, calculate the gradient of AD. Calculate the gradient of AD. Here is AD now. AD is on this line. Yes, this is AD. Right. Where do we start? Of course, we need to check first. Do we have 2 points on this? Remember, for you to determine the gradient, you need to have 2 points. Now, do you know the coordinates of A? Yes, we know the coordinates of A. Do you know the coordinates of D? No, we don't have the coordinates of D. Now, what is it that we're going to do now? Yes, I can see now some of you are pointing at C. Why are we supposed to use C? Yes, because when you look at A, C, D, these points are on the same line. These points lie on the same line. Therefore, the gradient of AC is equal to the gradient of CD, or the gradient of AC is equal to the gradient of AD. That is now we are going to say the gradient of AD here, which is the same as the gradient of AC, is equals to y2, which is 7 minus 4. Then we divide it by what? By 3 minus 3. Of course, that is a 7 minus 4 there. That is a 3. Now 3 plus 3, negative times negative is a positive. Then now the answer there will be what? Will be 6. Now then the final answer there will be a 1 over 2. That is a half. 3 divided by 6, it's a half. Right. Now we have the gradient of AD, which is a 2 marks question. The next question says now, you determine the gradient of BC. Determine the gradient of BC. Where is BC? Here is BC, right? You can see the BC there. Do we know the coordinates of B? Yes, we have the coordinates of B as well as the coordinates of C. Of course, now I can now say x1, y1, and now x2, y2. Right, now 5.1.2, boys and girls, now the gradient of BC. The gradient of BC, now we have what? We have y2 there is a 4 minus 6. Good. That is a 4 minus 6. We divide it by what? Minus 3 minus 1. And now the answer there, 4 negative times negative is a positive. Now 4 plus 6 is a 10. We divide it by minus 3 minus 1. Of course, that will be a minus 4. Right, from here now we can see now this will be 5, then minus 2. When you simplify it, we're going to get a minus 5 divided by what? Divided by 2, which is the same as 2,5. But I will be happy when you leave it as a fraction. Don't write it in decimal form. Right, now from here, boys and girls, you must also learn. Look at the line. If the line is to this direction, you know that you are going to have the positive gradient. And also if the slope is on this direction also, you are going to have what? The negative gradient. Each and every time when you work out the gradient, look at the line first and check the sign. Is it positive or negative? This one will help you to check your final answer. Right, now 5.2. 5.2 now says you must calculate now the size of DC. You must calculate now the size of DC. How do we calculate the size of DC? Here's the DC, that is DCB. Then it means we are looking at this angle here. We are looking at this angle here. That is angle DCB. Please, boys and girls, when you look at it like this one, you can think that this is 90 degrees. They did not say AD is perpendicular to what? To BC. First, make sure that you prove. If you can see down, this is perpendicular. That's when now you can say DCB is 90. But beside that one, you need to work it out to make sure that it is 90.